Here we will talk about a new type of transformation called a reflection. So think about looking into a puddle of water or lake that's really still. You see your reflection, or in a mirror, you see a reflection. Everything is flipped, everything's backwards. So reflection is when you take a shape and you pick it up, turn it over, and flip it. That's called a reflection. So what's going to happen is just everything is flipped. So here, circle the transformation that is a reflection. Look to see which two shapes are exact opposites of each other. So in this first one, we see it looks kind of flipped, but it looks kind of turned as well. That one's not a reflection. This last one is just a translation where it just slid to the left. So this middle one is what we would call a reflection. If you look and you were to connect all those points, they mirror each other. They're a mirror image of each other. So if I were to draw a line down my y-axis, I see that C is the same distance away from the y-axis as C prime. That's a reflection. So which graph shows a reflection across the x-axis? So I'm just going to highlight my x-axes here and see which shape flips over top of my x-axis. This first graph here is just a translation sliding it down. That is not a reflection. Nothing flips. The second one is a reflection because if you look, both shapes are mirror images of each other. The original, the triangle on the left, flips over our y-axis to get our triangle on the right. That is not a reflection over the x-axis. That would be a reflection over the y-axis, because if you look, D is 1 unit to the left of the y-axis, 1 unit to the right is D prime. E is 4 units to the left. If I go 4 units to the right, there is E prime. F is 3 units to the left. F prime is 3 units to the right. That's showing a reflection over the y-axis, which means 3, this graph right here, is a reflection over the x-axis. So in your own words, define reflection. Well, we need to write this down: a mirror image of an object when a shape is flipped over a line of reflection. You can paraphrase if you want or come up with your own, but that is our basis basic definition of a reflection. So here is arrow notation. We should be familiar with the arrow notation from translations. Same with reflections here. This would be a reflection over the y-axis, as you can see. The y-axis is halfway between all the points, the original and its image, so that would be a reflection over the y-axis. So here, let's use arrow notation and give the coordinates. So P reflects to P prime, which is the point -2, 3. Q reflects to Q prime, which is the point 0, 1. R reflects to R prime, which is the point -3, -2. And S reflects to the point S prime, which is the point -5, 0. What line is the image reflected over? Well, to find the line of reflection, so if I go from P to P prime, I went 1, 2, 3, 4, 5, 6 units, and reflection is always halfway between there. So half of 6 is 3, so this line right here, see how I go 1, 2, 3? There's my line. That line is my line of reflection, so the line of reflection in this case is x equals 1. So describe in words how to map our image to, or our original shape, to our image. The line directly between each coordinate and its image is the line y equals -1. You can see that in purple right here. That is the line y equals -1. All the points in the original image are the same distance away from the line y equals -1, our purple line, as the points in its image. So we can just pick one point and its image. So if I pick M, M maps to M prime. And if you look, that's 4 total units. Half of 4 is 2. 1, 2, so there would be your line of reflection, which is the line y equals -1. So here are the vertices. We want to find the image after reflecting it over the x-axis. Here's my x-axis. So I find C is 1 unit above the x-axis, so I go 1 unit below. There is C prime. B is 4 units above the x-axis, so I go 4 units below. There is the point B prime. A is 3 units above, so I have to go 3 units below my x-axis. And there is my triangle, my image, A prime, B prime, C prime. If you reflect triangle JKL across the y-axis, we just want the coordinates of point J. So here's my y-axis. I see J is 1 unit to the left, so I go 1 unit to the right, and that is J prime. The coordinates of J prime are 1, 1. Reflect the triangle over or about the line, x equals -1. So my purple dotted line is x equals -1. Point A is 3 units to the right, so 3 units to the left is A prime. C is 6 units to the right, so 6 units to the left is C prime. B is 1, 2, 3, 4, 5, 5 units to the right, so I go 5 units to the left, there is B prime, there is my image. Now we want to reflect over the line y equals -2. I see A is 1, 2, 3 units above. So I go 3 units below. There's A prime. B is 5 units above. So I go 5 units below. There's B prime. And C, 1, 2, 3, 4 units above. So I go exactly 4 units below. There is C prime. There is my image. And that is how we reflect, and thus how we determine our line of reflection.